All right, welcome to the lesson for factoring binomials 2. Let's just quickly review some stuff about multiplying binomials before we talk about factoring binomials. So usually when two binomials are multiplied together, it makes a trinomial. Okay? So for example, x plus 1 times x plus 1 equals x squared plus 2x plus 1. So two binomials multiplied together equals one trinomial. But sometimes it produces a binomial. So for example, x plus 1 times x minus 1 equals x squared minus 1. X plus 4 times x minus 4 equals x squared minus 16. X minus 7 times x plus 7 equals x squared minus 49. If you remember back to our lesson on FL, we called these hidden trinomials. Okay? And we called this the FL method because we know the middle two steps of FOIL will always cancel when we see the above pattern. So I have to FOIL this to get this, but when I see this pattern, I know I don't have to do the whole step. I can just square the x and square the 1 and put a subtraction between it. Okay? And the pattern we look for is same terms, opposite operation. Okay? So you want one addition and one subtraction. Addition, subtraction, addition, subtraction, subtraction, addition. Okay? So now we're going to look more at these hidden trinomials. Well, first, back in factoring binomials 1, we learned that we can be given a trinomial plus 1, and we can work backwards and factor it. So we know the first two terms have to be x's because that's the only way to get x and x. I mean the x squared. So then the 1, we know 1 and 1 equals 1. So we get the x plus 1 times x plus 1, okay? Sometimes it's more complicated than that, obviously. But now, what would you do if you were given something like this? X squared minus 1. How would I factor that? So, before we factor it, let's just go back. We said x plus 1, x minus 1 is equal to x squared minus 1. No, let's not use this example. Let's say x plus 4, x minus 4 equals x squared minus 49. So let's look at the result. Squared term. Squared term. Subtraction. Okay? So if I were to be given another instance of this, I would be able to then, because this direction is multiplication, but now I want to factor it. So if I was given this pattern and I was asked to factor it, well, one, I know I want two binomials. I know it has to be these x's because of that x squared. And again, whether it's FOIL or FL, the last two terms, there's also the square of the last term. So this would have to be 7, and this would have to be 7. Now we know we can't have two addition signs here because that would give us this. But if we think back to the FL method, we know one has to be addition and one has to be subtraction here. Okay? All right, so we're just going to look at a few more examples. A few more examples of this. So now we're going to look at 9x squared minus 25. And we need to figure out which two binomials factor. All right. Is this a perfect square? It is. Is this? It is perfect, and we have subtraction. Okay, so we know that this is a hidden trinomial. All right, so really what that looks like is 9x squared plus 0x minus 0x minus 25. Okay, well, that's not a trinomial, but then it would, if that's what you would do if you did the whole FOIL. But then if you simplified real quick, you would just get this. There, and this is the hidden trinomial. All right. So what times what equals 9? 3. What times what equals x squared? X. So we know these have to be 3x because 3x times 3x equals 9x squared. Okay, same thing with 25. What's the square root of 25? 5. 5. Because 5 times 5 equals 25. And like we said, one just has to be addition and the other is subtraction. All right, so let's look at two more examples. 4x squared minus 121. Okay, perfect square, subtraction. So we know we can do it. Square root of 4 is 2. X times x gives me that x squared. So I'm just going to write it out for y'all. 4x squared. Square root of 121 is 11. Because 11 times 11 equals 121. And we just throw that addition or subtraction in there. Okay? I could do subtraction here or in addition here if I want. It doesn't matter. All right, last one. 16x squared minus 75. Okay, so this is perfect. Subtraction, not perfect. All right, so our pattern doesn't hold. Pattern does not hold. But does